Okay, some more things about rational equations, right? So we have a function on top and a function on bottom. So some things we need to understand are, number one, the zeros. What are zeros? Zero are where your graph crosses the x-axis. Okay, your x-axis intercepts, or your x-intercepts from your x-axis. X-intercepts. That's where your graph crosses the x-axis. Okay, that always comes from your numerator. Whatever equation is in your numerator is where you get your x-intercepts from. Okay, you set your numerator equal to 0 and you solve. And then, of course, your denominator, if your denominator is 0, that's where we have your vertical asymptotes. Right? Anything left in your denominator is a vertical asymptote. So if we're finding solutions, right, those come from your numerator. And if we're finding vertical asymptotes, those come from your denominator. Okay, so it's important to know what you're looking for depending on what you're asked to find. Okay, because now we're going to throw in this word inequality again. So we have greater than, less than, greater than or equal to, right, all of these things. When is our graph above or below the x-axis? That's what we're trying to figure out. When is our graph above or when is our graph below the x-axis? And your answer is always an interval. Okay, so take a minute to read these steps, right? Because these are the steps that we're going to do every single time we find a inequality. Okay, number one, set your equation equal to 0. Okay, pretty basic. Most of them already have that done. Number two, make sure it's in a rational type of an equation. Okay, so you have a function over a function. Okay. Number three, find the zeros and find the asymptotes. So this is what we're going to do for the most part during our math. We're going to find the zeros. That's where your numerator equals 0. And we're going to find your asymptotes. That's where your denominators equal 0. Okay, so we're going to do some math, right? We're going to solve some things in order to find where our zeros are and where are your vertical asymptotes. Because then we're going back to making a sign chart. And if you've forgotten what a sign chart is, this video will remind you, hopefully, of what a sign chart is. We're always looking for intervals where our graphs are positive and negative. Okay, so we use our zeros, we use our asymptotes to make intervals that we're going to be checking. Okay? Let's see. We test some values to see if our values are positive or negative. Right? Positive is where your graph is above the x-axis, and negatives are where your graph are below the x-axis. Okay? And then, of course, we write it in interval notation. So let's jump in here on example 1. Solve when is this rational equation greater than or equal to 0. So what types of numbers are greater than or equal to 0? We are looking for positive numbers. Positive and 0, right? 0 does equal 0. So where is it above the x-axis? Where are our values positive? And where are our values 0? So your zeros, we'll do those first. Where do your zeros come from? Your numerator. X minus 2 equals 0. You set your numerator equal to 0, and we have a 0 at positive 2. Okay? So we're going to come down here with our sign chart. So you make a horizontal line, right? A number line. And we're going to put our first value of positive 2 on here, and we have a closed dot because this is where it equals 0. So we're going to put a dot there at positive 2 representing our 0. This is where our graph crosses the x-axis. This is the only place where our graph crosses the x-axis. Okay, so you take your numerator, you set it equal to 0, and you solve. So now let's look at our asymptotes. Okay, those come from your denominator. We're going to have two of them, it looks like. X plus 6 equals 0, and where x minus 3 equals 0. So you take both of your factor denominators. Right? So you have to factor it and solve. So this one's already factored for us. You set each of your factors equal to 0, and we have a vertical asymptote at -6, and we have a vertical asymptote at +3. So +3 is over here to the right, and we put an open circle there because it can never equal +3, and we're even going to put some dashed lines to tell ourselves that this is in fact a vertical asymptote. Okay, same thing with -6. We'll come over here to the left, put an open circle, and then we will put in our dashed lines, reminding ourselves that's an asymptote, not an answer. So now let's get to our next part, which is figuring out whether we're positive or negative. So we're going to pick any number to the left of -6, right? A nice one might be -7. And we're going to plug -7 in for all of our x's up here in your problem. Okay, remember, we're only looking for positivity. Is our value positive or negative? So we have -7 minus 2 over -7 plus 6 and -7 minus 3. Okay, so you're plugging in -7 for all of your x's, every single x that we have. And now let's evaluate. What's -7 minus 2? Well, that's a negative number. So our numerator is going to be negative. -7 plus 6 is a negative number, times -7 minus 3, which is a negative number. So what's a negative times a negative? Positive. So our denominator is going to be a positive value. Our numerator is going to be a negative value, which means our fraction is going to be negative. So everything to the left of -6 will give me a negative value. I am picking one number and I am trying to see whether it's positive or negative. Okay, it's negative, which means it's not part of our answer because we want positive or 0. So now let's pick something between -6 and +2. How about 0? Math with 0 is pretty okay. 0 minus 2, that's a negative. 0 plus 6, that's a positive. 0 minus 3, that's a negative. So what is a negative divided by a negative? That's a positive. So anywhere between -6 and +2, right? That's our interval. Everywhere between -6 and +2 is going to be a positive value. That's exactly what we're looking for, are positives. Okay, now we'll check between 2 and 3. Right, 2.5. So on our top, 2.5 minus 2 is positive. 2.5 plus 6 is positive. 2.5 minus 3 is negative. So a positive over a negative is a negative. In between 2 and 3, we have negative values. And then anything bigger than 3, we have, let's see, 4 minus 2 is a positive. 4 plus 6 is a positive. 4 minus 3 is a positive. Anything bigger than 3 is positive. Okay, so this is us doing our sign evaluation. We are finding out whether we have positive intervals or negative intervals. Okay, so we want positives or 0. So that's between -6 and 2, but 2 gets a bracket because it's equal to 0 when it's +2. So that's one of our intervals. And our other interval is from 3 until forever or infinity. Okay, so we have from -6 to +2, that is one interval where our values are positive, and then we have from 3 to infinity, that's our other interval where we have positive values. Okay, how about example 2? Now we have a rational function that's less than 0. So we're looking for all of the possible negative values. Where is it less than 0? Okay, so we have two things to calculate. The first thing are the zeros, and the second thing is the asymptotes. So where do your zeros come from? The numerator, x squared minus 4 equals 0. So let's solve this. Add 4 to both sides, x squared equals 4. Take the square root. What's the square root of 4?
2.
And negative. When we take a square root, we get two values. One is positive and one is negative. Okay, always when we do algebra and we're solving by square rooting, we get a positive value and a negative value. So let's put those on our number line. -2 gets a closed dot. +2 gets a closed dot. Those are both zeros. Now let's look at our vertical asymptotes. That comes from your denominator. So x squared minus 10x plus 5, no, not plus 5, plus 25 equals 0. So we have ourselves a quadratic. Okay, so in our brains we need to think what numbers multiply to give us 25 and add to give -10. What numbers multiply to give 25 and at the same time add to give -10? Good, -5 and -5. So x minus 5 and x minus 5. So how many x minus 5 factors do we have? We have 2 of them, which means we're going to only have one solution, which is x equals 5. Right? So we have one solution, but it would have a multiplicity of 2, but we're not really concerned about this multiplicity right now. We're just going to add it in there as a asymptote. Okay, so we have through 4 intervals. We have everything less than -2. We have between -2 and +2. We have between 2 and 5, and we have everything greater than 5. Okay, so we're going to do the same analysis. We're going to plug in 4 values. How about -3 and then 0, right? 0 is good. We'll plug in +3 and then plug in +6 and see whether we get positives or negatives. So we're looking for all of the possible negative values. And where do the negative values occur? Between -2 and +2. So parentheses, -2, +2, parentheses. Right, we don't want or equal to, so we use parentheses, not brackets. Okay, parentheses, not brackets. So we have 4 other examples. We're going to run through them pretty quick because they're all done the exact same way, and I want to get to the bottom before they're too long. So I'm going to pause the video. We're going to do all of these, and we'll come back and talk about their answers. So here are all of the answers to these 4, right? We have to do 2 things every time. Find the zeros from your numerator, find the vertical asymptotes from your denominator. And then you check your intervals to see whether they are positive or negative. Okay, so if you're following along on the notes, pause it right here so you can copy down what's going on, and then make sure that you know how to do it on your own, with your own math. Okay, because the last thing is, what happens if we have a graph, right? So graphs are pretty nice to interpret because they give us all the answers, and we just have to find what we need. Okay, so what values are less than or equal to 0? What are we looking for on the graph? Less than means we have negative values. Where do we find negative y values? Below the x axis. So we're being asked to find all the places where our graph is below or on the x-axis. So let's see, it looks like that happens here in the middle. Here our graph is below the x-axis, and then it touches at -1. So our interval is from -3 to -1, right? So -3 gets a parenthesis because that's an asymptote. -1 gets a bracket because that's a 0, right? So we put brackets on zeros because it says or equal to. And then where else is it below the x-axis? In between 2 and 3. Okay, anytime our graph is below, less than means below. So that would be a union of +2 to +2 to 3, not infinity. It's a real short 1 unit interval. So that's all the places it's below or on the x-axis, right? Or equal to 0. That means we're going to have brackets where we cross the x-axis. Okay, next we have when is it greater than 0? Greater than or positive. Positive values are above. When is the graph above the x-axis? From off the graph all the way to -3. And then we have this little gap in between here where it's once again above the x-axis between -1 and 2. And then it's once again above the x-axis from our asymptote off to the end. Okay, so this one has 3 intervals where we are above the x-axis, always with parentheses because it's not equal to. -1 to 2 above the x-axis, and then finally from 3 to infinity. So anytime we're not equal to, we have to use parentheses. Okay, or equal to means brackets. Okay, our last question says, when is our graph greater than +1? So when is our graph above y equals 1? Okay, so above y equals 1, that means we're looking at your asymptote, right? This is the asymptote that describes y equals 1. So when is our graph above this horizontal line? Well, everywhere until we get to -3, right? A -3 becomes way down, and then still below up until we get to +3, and then it continues on forever. So these are all the places where our graph is above. I mean, I don't think it's ever going to be equal to because it's an asymptote. So -infinity to -3. That's where our graph is above the horizontal asymptote. And then we have again from +3 to infinity. That's the other place where our graph is above the asymptote. Okay, so if it's 0, that's an x-axis. And if it's a y equals, well, that's a horizontal asymptote. Okay, so there we are solving rational inequalities.